Welcome everyone. In this video, I'll go through the first of 3 videos covering an AQA A-level chemistry exam question on organic synthesis. Question details are at the end. Let's get started. Here's the background information required for this question. You might want to take a quick photo to refer to during the video. And here are the questions that we're going to look at. You can press pause and try the questions yourself first. The first part of the question is about anti-bumping granules that are used during reflux. Reflux is the continual boiling and condensing of chemicals in a reaction mixture. Heat increases the rate of reaction. A condenser prevents gaseous substances from escaping. The photograph on the right shows how the apparatus might be set up for a reflux in the laboratory. The diagram on the left shows the same apparatus. You could be asked to draw a diagram like this in an exam. When liquids boil, bubbles form. Large bubbles that form during reflux are called bumps. Bumps can lead to chemicals escaping from the top of the condenser, which is dangerous. Anti-bumping granules are placed in the round bottom flask before heating. We generally use about half a spatula. They are porous and inert. Small bubbles form inside the pores and are released. The photograph on the right shows a 200 ml container of anti-bumping granules with some of the anti-bumping granules poured into the lid. To address the question, anti-bumping granules prevent the formation of large bubbles. Here's the next part of the question. Show by calculation that an excess of sodium hydroxide is used in this reaction. We've got 5 centimeters cubed of ethyl benzoate. The density of this is 1.05 grams per centimeter cubed and it has a molar mass of 150. This is added to 30 centimeters cubed of 2 mol per decimeter cubed sodium hydroxide. We can work out the mass of ethyl benzoate by multiplying density by volume. Density is given in grams per centimeter cubed, volume is given in centimeters cubed, so 1.05 multiplied by 5.0 gives a mass of ethyl benzoate of 5.25 grams. We calculate the amount of ethyl benzoate in moles by mass divided by molar mass. 5.25 divided by 150 gives us 0.035 moles for the first mark. Next, we calculate the amount of sodium hydroxide. This is given by concentration by volume. Because the volume is in centimeters cubed and the concentration is in moles per decimeter cubed, we need to divide the volume in centimeters cubed by 1000 to convert this to decimeters cubed. 2 multiplied by 30.0 times 10 to the minus 3 gives an amount of sodium hydroxide of 0.06 moles. Times 10 to the minus 3 is the same operation as dividing by 1000. This is a 1-to-1 reaction. 1 mole of ethyl benzoate reacts with 1 mole of sodium hydroxide. The amount of sodium hydroxide is greater than the amount of ethyl benzoate, so the sodium hydroxide is in excess. The amount of sodium hydroxide gains the second mark. Next, we have to suggest why an excess of sodium hydroxide is used. In order for a reaction to occur, reactant particles have to collide. To maximise the chance of a collision between reactant particles, we often use an excess of one of the reactants. To address this part of the question, an excess of sodium hydroxide is used to ensure that all of the ester reacts. Finally, we have to suggest why an electric heater is used rather than a Bunsen burner in this hydrolysis. The ester reactants and alcohol product are flammable. Most organic substances are flammable, so using an electrical heating mantle is the safer choice. An electrical heating mantle is shown in the photograph there on the right. It's the piece of blue electrical apparatus. I would always choose to use this piece of apparatus if available. It's easy to control the temperature and probably easy to set up too. If that helped, watch this next video and subscribe for more chemistry explained. There are links in the description to videos explaining the answers to the rest of question 3 from the same paper. Any questions or topic requests, just post in the comments. Take care and good luck with your studies.